Unveiling the intricacies of nuclear power plants, how they work. Nuclear power plants have been a topic of both fascination and controversy since their inception. They are a crucial part of the global energy landscape, providing a significant portion of the world's electricity. To understand the functioning of nuclear power plants, one must delve into the intricate processes that harness the energy released from nuclear reactions. This podcast aims to provide an in-depth exploration of the workings of nuclear power plants, shedding light on the science, safety measures, and environmental implications involved. So, how does a nuclear power plant work? Let's go in parts. We start step by step. Nuclear fission. The core principle. At the heart of a nuclear power plant lies the process of nuclear fission, which involves splitting the nucleus of an atom, releasing an immense amount of energy in the form of heat. Uranium-235, U-235, and plutonium-239, Pu-239, are the primary isotopes used for nuclear fission. In a controlled chain reaction, these isotopes release neutrons that collide with other nuclei, resulting in a self-sustaining reaction that generates a substantial amount of heat. The reactor core. Generating heat. The reactor core is the central component of a nuclear power plant where nuclear reactions take place. Fuel rods containing U-235 or Pu-239 pellets are arranged within the core. Control rods, made of materials that absorb neutrons, are inserted between the fuel rods to regulate the reaction. By adjusting the position of these control rods, operators can control the rate of the nuclear reaction, ensuring it remains at a safe and stable level. Heat transfer and steam generation. The heat generated within the reactor core is used to produce steam. This heat is transferred through a coolant, often water or pressurized heavy water, which flows around the fuel rods. The coolant absorbs the heat and then transfers it to a secondary loop, which turns water into steam using heat exchangers. This steam is then directed to drive a turbine. Turbine and generator, generating electricity. The high-pressure steam from the heat exchangers drives a turbine, a large rotary machine. As the turbine spins, it converts the kinetic energy from the steam into mechanical energy. The turbine is connected to a generator, which converts this mechanical energy into electrical energy through electromagnetic induction. The generated electricity is then distributed to the grid for consumption. Cooling systems, managing heat. Maintaining a proper temperature within the reactor core is essential to prevent overheating and potential meltdown. Nuclear power plants utilize cooling systems, often involving large bodies of water, to dissipate excess heat. Once the steam has passed through the turbine, it is condensed back into water and returned to the heat exchangers, creating a closed-loop cycle. Safety measures. Preventing accidents. Safety is of paramount importance in nuclear power plants. Multiple layers of safety systems are in place to prevent accidents and mitigate their potential consequences. These include redundant cooling systems, emergency shutdown mechanisms, and containment structures designed to withstand extreme scenarios. Waste management. Handling radioactive materials. Nuclear power plants produce radioactive waste, including spent fuel rods. Proper storage and disposal of these materials are critical to prevent environmental contamination. Some countries reprocess spent fuel to extract usable materials and reduce waste volume, while others store it in secure repositories. Environmental considerations. Pros and cons. Nuclear power offers a low-carbon energy source that can contribute to reducing greenhouse gas emissions. However, concerns over radioactive waste disposal, potential accidents, and nuclear proliferation are aspects that need to be carefully managed. Striking a balance between the benefits and risks of nuclear power remains a subject of ongoing debate. How does a nuclear power plant work? In summary, nuclear power plants represent a remarkable feat of engineering that harnesses the incredible energy potential locked within atomic nuclei. Through controlled nuclear reactions, these plants generate electricity that powers modern societies. The science behind nuclear fission, combined with stringent safety measures and waste management protocols, allows for the responsible utilization of this powerful energy source. As technology evolves and environmental considerations continue to evolve, nuclear power will remain a pivotal player in the global energy landscape, prompting ongoing discussions about its role in meeting the world's energy needs while minimizing its potential risks.